Logical operations on arrays. Anything that has to do with logic, so usually we were used to seeing the relational operators in this case. Now there's going to be one more function called find that will help us find where a matrix has valid data points. For example, anything that's linked to logic, true, false idea. Now the relational operators are well known by now, and they helped us look at the relation between two values. The relationship was x greater than 9.9, yes or no. We could even compare two variables without really knowing the numbers inside at all times. We want to know if x is greater than y, or if x is less than or equal to y. But now that we're learning about arrays, it comes to mind to wonder, like, what if x was an array? What if x was a matrix, a vector? Can we compare matrices? Can we compare vectors? So that's kind of the question about this whole lesson right here. Now the best way, of course, to answer these questions is to experiment. Remember, MATLAB has a command window, experiment with random things. Now with a simple little scalar, we could do check if x is greater than 0.5, and we'd get a 1 for a true, a 0 for a false. We'd immediately start building if statement with result like this. So that was something very straightforward with scalars. Now if I change my mind now and I'm kind of pushing further and I want to study a vector, the best way to create a vector for experimenting is rand function. So right here I have a vector, and I really wonder what happens if I do the exact same command, x greater than 0.5. As you can see, MATLAB looks at each element individually, so there is no error message, but MATLAB looks at 0.59, and that's above 0.5, so that gives a true. 0.81, that's above 0.5, so that gives a true, all the way up to the end of your vector. So comparing a vector with a scalar, MATLAB goes individually through each element. If you want to compare a vector with a vector, let's say we have two vectors, x and y. What happens if we ask MATLAB to say, is x greater than y? Well, MATLAB again compares every element. 0.59 was not greater than 0.9, so we had a false. 0.81 was greater than 0.45, so we had a true, and all the way like that to the end. So we can do relational operators on vectors as well. Of course, is how about matrices? So here's a random 2x2 matrix, and same thing, I want to know, is it greater than 0.5? MATLAB goes through every element, and notice how it gives us a result the same dimension as what we started with. When we had a vector, we got a vector of zeros and ones. Now that we have a matrix, we get a matrix of zeros and ones. So a matrix of true and false. Now, if we want to compare two things, there's one logical aspect of this, is that we can't compare two variables that do not have the same dimension. X is a 2x2, y is a 1x5. Even you and I right now would have no idea how to compare these two things. It doesn't make sense. We have 4 elements, 5 elements, they're not in the same location. It really is that simple. If we want to compare vectors or matrices, they have to have the same dimension, and that's all it comes down to. Now the question is, what happens when we put these kind of answers in a while statement or in a loop? Because right now we have x equals a random number. We have 5 values. So what if we tell MATLAB, while this vector is greater than 0, what does it mean for MATLAB? When such expressions are placed inside an if or a while loop, no matter, MATLAB implies an AND expression between each 1 and 0. We're obviously getting back a bunch of zeros and ones. So MATLAB looks at all of them and puts an AND statement between each. So it ends up being if all the elements of x are strictly positive, or while all the elements of x are strictly positive. MATLAB looks at each element. So is the first element positive? And then it looks at the second element, and it puts an AND statement in between. So if the first element and the second element and the third element is positive. So it is a very powerful shortcut. Instead of having to write the line on the bottom, which could be very long if we had 100 elements, all we have to do is rely on those logical operations. Now the other part is, what if we want to check multiple condition? Is x greater than 2, but is x less than 10 at the same time? This is something that was very easy with scalar. It is possible on arrays, but we have to do one little modification. If we stick to the old-fashioned way of putting 2 and %, we do get an error message. The only difference is now, if we're dealing with x as a vector or as a matrix, we just put 1 and %. It's the same with OR. We would just put one OR statements. In that case, MATLAB starts seeing zeros and ones. It starts evaluating element per element. So it's a good start. MATLAB would see if and a bunch of zeros and ones. It would eventually put the AND statements in between each, and then it would evaluate this whole zeros and ones to just 1 or 0. So just one true or one false. So the first example on this is data analysis. Suppose you have a file that has a bunch of grades, just one column. You don't really know how many, but we are asked to find how many people have above 100, have above 90, above 80, etc. The usual grade system. But we are told that some of the numbers are negative, for example, negative 9.9, and we are told to delete them. So we have a couple things to do, but we got to find logical expressions on something that has a bunch of values. As far as the algorithm, first load the grades from the file, and then calculate how many got between 100 and 110, between 90 and 100, between 80 and 90, and so on. Now, dealing with files, always check that your file is in the current directory. Desktop, current folder, and make sure that your file is here. If you don't see it here, make sure you use the ... to actually go get the right directory. Now, I always love to look at my file to see if it has any problems. I'm about to use DLM read, but if there is a symbol in there that makes no sense or a delimiter that's not unique, all of a sudden I couldn't use it. So I always double check. I'm looking for only numbers from top to bottom, which I have, so I'm okay. So now that I know that I'm in the right directory, I can start coding. So my numbers are all in one vector called my grades. It worked, and apparently I have 94 students in the class. So now that I know that it works, I can go and start working on the logical operations. Now, if it was just one single grade, how would I know that it's between 100 and 110? I would combine my grade is above 100 included, and my grade is less than 110. Now this was if I was only looking at one value, but now that I'm looking at a vector, remember to only put one AND statement. So MATLAB is going to look at this vector and give a bunch of ones and zeros when it's true and when it's false, and then look at this vector, which is the same, and compare it to 110. Then it's going to combine the two one by one. So I end up with a vector, a column vector, that has a false when the grade is not between 100 and 110, and it has a true when the grade is indeed between that boundary. But I'm not really asked to show zeros and ones. I'm asked how many of the students were in that category. So all I would have to do is actually count the number of ones, which is nothing but adding all these numbers right here. So sum of that vector. Run. For 90 to 100, it's very similar. 100. Run. So 11 comes from this line, and 53 had an A. We can keep going like this quite a while. But instead, I start seeing a pattern. I mean, if I did do it, I would end up with 80 and 90. So it's always a number and that number plus 10. A number, that number plus 10. A number, that number plus 10. So instead of rewriting forever and ever this, I would like to start a pattern. I'd like MATLAB to count for me. So a number and that number plus 10. And when we started at 100, then we started decreasing by 10. So that's a perfect for loop. I started at 100 and I decreased by 10 each time, and I'm going to stop at 0. So now I can sort of delete these two because they're going to be done by the loop. So there you go, 100, 53, 11, 6, 4, 1, 0, 0, 1, and 4. It would be great to actually check quickly, do all these numbers add up? They add up to 91, which sparks a question. I'm supposed to have 94 numbers, so how come I only have 91 that fit in the categories? If you remember from the client, we were told that some of the numbers were wrong, the negatives were wrong. So instead of stopping at 0, I'm going to stop at negative 10. And here are my 3 missing students. So now I can make all this pretty, now that I know that it works. This counts how many, and I'm going to do a quick fprintf. So between this number and that number, I have so many students. The lower limit was always x, the upper limit was x plus 10, and the number of students was NBS. And it was even included on the bottom. So there you go. Now that I know that my numbers were correct, I make it pretty with fprintf, not before. Between 100 and 110, I have 11 students, and so on. I can even make it all aligned. The first column should take up to 3 digits. So here's a 3, that one same thing, and the number of students always up to 2 digits. So now everything aligns. Okay? Now the client did want us to delete the negatives, which we haven't done yet. So before I actually analyze the file, I need to delete the negatives, which is the same logic as logical operation. I want to find where all the numbers are negative. To delete, though, back to a previous lesson, is this idea. Delete from a variable. Now we have 3 variables on the right. We want to delete the grades. So the variable that we want to delete from is my grades. Here, if I put a 1, I'm going to delete the first grade. If I put an and, I'm going to delete the last grade. A 6, I'm going to delete the 6th grade. But I don't really know where they are located. So that's the greatest thing about MATLAB. We don't really need to know. We need to tell MATLAB, when that condition is true, please delete from this variable. So when that condition is true, my grades is negative, MATLAB will automatically figure out the positions and delete them. So now as soon as I run, notice I now have 0 students that are below 0. Final add-on. The client emails us quickly and says they also want to know who got those grades, so what positions. And before deleting the errors, they want to know what student number it was, so maybe they can go fix it. So now we're interested no longer by the zeros and ones, not the trues and false. We're interested in which position satisfied the condition. So where were the trues, where were the ones? And there's a function called find, and then from the help it says it finds the indices of non-zero elements. The indices is the vocabulary word for position. So it finds the position of non-zero elements, and it's really easy to use. I equals find of x. X may be a logical expression, so we can use the logical operations, the greater than, less than, inside the parentheses, and MATLAB will return the indices as a return value. So as far as showing which grades were bad, we want to find the positions. So bad grades equal, find the position where they were bad. And for a grade to be bad, it had to be strictly less than 0. So by running this alone, I have 11, 27, and 74. Those 3 students' position were below 0. So now that I have that, I can do a quick display message. I prefer to use disp in this case since I don't have to figure out a placeholder, and I decided to transpose so it wouldn't take 3 lines but only 1. So invalid grades on line 11, 27, and 74. Again, finds the position where this condition was true. Same pattern for below to actually show the student ID number. For each one, so IDs equal find, and it's the same condition that we used to actually sum them. But instead of summing the 1 and the zeros, I want to find where the ones were. And same idea, disp, IDs, transpose, run. So 11 students, those were the IDs. 53 students, a lot more, so all the ID numbers. 11 students between 80 and 90, and so on. So it's a really powerful function that we can use to not only figure out when the condition is true, but also what line specifically it was. So this concludes this small code. Very little lines if you notice, but very powerful line. This is a very powerful line. There's a lot of things going on behind this line. There's a for loop, there's an if statement that we don't have to code, but somebody coded it for us. As far as vocabulary, we saw index. Indices is the plural of index, but it means the position. Logical is anything that has to do with true and false. Now, logical expressions can work on arrays too. It returns a 1 or a 0 on each element, and it returns a variable that has the same dimension as the original one. It works on vectors and matrices. It uses find to actually obtain the position where the condition was true. So if you don't really care about the zeros and ones, but you more are interested with what position was it a 1, then we use the find function. This is something that's really powerful with MATLAB. Java and C and other languages don't have that opportunity. So even if you have some programming background, make sure you hit replay if you didn't understand all of these ideas.